Good day, I'm Dr. Ting, and in this module, we are going to look at big data. The fundamental of big data. Big data is defined as any kind of data source that has at least three shared characteristics of 3V. But in fact, we have many V's coming on, like 5V's or 6V's in many research. The 3V, the commonly known characteristic of big data, will be the big volumes of data, the volume V, first V. The second V will be velocity of data, which means how fast your data can be collected per day or per minute, and variety of data, the different kinds of data that you collected. Waves of managing data. The first wave will be creating the manageable data structure in which in the early of or in the late of 1960s, data was stored in flat files like Word file or Excel file that imposed no structure at all. Then later on in 1970s, things changed with the invention of relational data model, relational database. You have rows and columns, so we have this relational database management system, and then the data warehouse solve the data management problem. So this is the first wave. We have RDBMS, we have SQL to manage and to manipulate your data. In Web 2, we have web and content management. The enterprise content management system evolved in 1980s to provide businesses with the capability to better manage their unstructured data and mostly their documents. And then in the 1990s, with the rise of the website, the web, the www, the internet, organization want to move beyond their documents only, and I want to store and manage web content like images, audios, and videos. So this is a new generation of metadata system. Then in the third wave of managing data, this will be big data in which it can be stored. You can store your data and visualize the data, manage your data utilizing cloud-based storage, which is more cost effective, and then improvement in the network speed because of the big data and reliability. You have to increase the reliability of your network. Then you have to remove like physical limitation of being able to manage your massive amount of data in an acceptable pace. So you need to actually improve your computer systems, improve your network, improve your cloud storage, improve your software in order to manage this big data. Why is big data important? The importance of big data doesn't simply revolve around how much data that you have. In fact, big data is important. The values of big data comes in when you know how to use your big data. By taking data from any source and analyzing your big data, you can find answer like streamlining your resource management. You can improve operational efficiency. You can optimize your product development. You can drive new revenue and growth opportunity. You can enable smart decision making through big data. When you combine big data with high performance analytics, you can accomplish business related tasks. For example, you want to determine what is the root cause of your failures of your project, the issues and also defects in the near real time. Spotting anomalies or abnormal faster, you can spot this abnormality faster and more accurately than the human eye. You can improve patient outcomes by rapidly converting the medical image data into insights. Means you have a lot of medical image data and you can process, analyze the data and come out with a solution or with an insight, with a model to tell you what is happening. Recalculating entire risk portfolios in minutes. Sharpening deep learning models' ability to accurately classify and react to changing variables. Because especially in machine learning models, you will need big data, a lot of data. big data sets in order to train your machine to become intelligent enough to interpret or to come up with the outcome that you would like to have. You'll be able to detect fraudulent behavior before it affects your organization. These are some use cases of big data. The first, product development. For example, Netflix, Procter and Gamble use big data to anticipate customer demand. They have this so-called predictive. They have these predictive models for new product and services by classifying the key attributes of past and current products or services, modeling the relationship between these attributes and the commercial success of the offering. So based on the past historical transactional data that they've collected, they can actually identify certain attributes that is closely related to predict the customer demand. And based on this, they come up with the predict models to predict our customer preference. Predictive maintenance factors can predict your mechanical failures. Like for example, you have the year, the model of equipment of your hardware, for example, and then you might have like data about your log entries, who is using this and who is using that at what time, how intensively it is used, sensor data, error messages, the engine temperature of your hardware. Then from all of these factors, you can actually try to find out how long you can still use this machine and predict when we will need to carry out maintenance in order to prolong the lifetime of your machine. Customer experience is another big data use case, very popular. You can make use of this data which you gather from social media like Facebook, especially the web visit, the call logs, other resources to improve interaction, experience, and maximize the value delivered. So this will involve the text processing, natural language processing, in order to extract the customers' preferences or demands from this big data set from different resources. And then you start to deliver the personalized offers, reduce the customer churn, handle issues proactively. Another big data use case will be fraud and compliance. When it comes to security, it's not just a few hackers. You are up against entire expert teams, and therefore we will need to actually identify the patterns in the data. When you have a big set of data, you'll be able to identify how the hackers are actually hacking to your system and where they are, which network that they will prefer to do the hacking, and so on and so forth. So this big data will be able to help you to identify this fraud. Machine learning is a hot topic, and data, especially big data, is one of the reasons why we need this. This is because we need them to teach the machine. If the big data is not big enough, you will not be able to test your model and then validate your models, because all this will need big data to train your machine. Operational efficiency may not always make the news, but it's an area in which big data is having the most impact. With big data, you can analyze the assess your production, your customer feedback and returns, and other factors to reduce outages, and anticipate future demands. Say, for example, you have daily transaction from the customers. So from there, you can do the market analysis to predict what your customer like. Drive innovation. Big data can help you to innovate. Innovate by studying interdependencies among humans, institutions, entities, and process, and then determine new ways to use these insights and use the insight to improve the decision making about your financial and planning considerations, examine trends, what customer want to deliver in order to deliver new products, services, and implement dynamic pricing. Now let's take a look at big data management architecture. This figure on the left hand side illustrates that data must first be captured. So this is an technology that you need to install. For example, a transaction from transaction processing system, you can capture daily transaction from the retailers. But for industry, say for example, you will need to include perhaps IoT or IoE, Internet of Things devices to capture your smartphone, smart home. You will need to include all these devices or sensor from the IoE or IoT in order to capture the big data. And after this, you will need to integrate all your data into one data warehouse, or else it will be from different resources. And sometimes they might not comply with each other, the data format. So you will need to cleanse it, you will need to transform it in order to organize it into one data set. After this phase is successfully implemented, data can be analyzed based on these issues or based on whatever outcome that you want to reach the result. And you must know what is the problem that you want to solve in order to start the analysis. You can just start analysis without knowing what you want to do. The integration part will be the integration of different resources, especially. Say, for example, you might have a lot of resources from YouTube, which is in video format, but then you have a lot of text-based format of data from social media like Facebook. You got the comments from the Facebook, and then you might have digital numbers data from the logs, and therefore how are you going to integrate all these different kind of resources? Then after you analyze, okay, you will need to take action based on the outcome of your analysis. For example, if you analyze and you got to know that your customer would prefer to buy certain group of car accessories during winter season, then you will have to take action in order to fulfill this high demand during the winter. So you might want to purchase more from the supplier, especially for this category of product. For example, Amazon.com might recommend a book based on the past purchase, or a customer might receive a coupon for a discount for a future purchase of a related product to one that was just purchased. So this kind of service we call it as personalized service, is possible. You can carry out this based on the big data analysis. So we have gone through the basic introduction, the 3 V's, the characteristic of big data, and you know that big data basically means it's big in volume. It comes very fast, velocity, and also variety, different kinds of data sources. And what are some example of big data use cases? And then also the architecture, the big data management architecture. And with this, you should be able to know how this big data is integrated into the whole technical or whole technological architecture of your system, if let's say your company involved with big data. With that, that's all for this module. I will see you again in the next video.